4.6, combinations. So 5 cards are dealt to each person in a card game. How many ways can you be dealt a hand that only has red cards? So that would be all these, how many ways out of these red cards can you get? 5 is basically what we're answering. So there's 26 cards, and you want 5. So what we're going to do is it's going to be 26 over 5 factorial, 21 factorial. So remember that 5 and 21 add to be 26. So that's what we did last section. Okay. Each year during the Festival de Voyageur, held in February in Winnipeg, Manitoba, high schools compete in the Voyageur Snow Sculpting Contest. This year, Amir's school will enter a 3-person team. 9 students have volunteered to be on the team. How many ways can a team of 3 snow sculptures be chosen? Okay, so what he did first of all, 3-person team with 9 volunteers. So what he did is he looked at all these different ways. He said NPR, how many permutations, where N is 9 and R is 3. So he got that there are 504 ways. Okay, this is when order matters, but in this situation, they only want combinations. Therefore, we need to divide. The teams listed on the previous page all involve Amir, Connie, and Bill. So all of these have Amir, Connie, and Bill, just different ways. And there are 6 different ways to do that. So each, these 3 students can be arranged in 6 different ways. This is true regardless of which 3 students are chosen. So there's 6 ways to choose 3 students. So what he's going to do is now he's going to take that number and divide it by 6. So therefore, there are 84 different teams. Why was it necessary to divide by 3 factorial? Because it gives a number, this 9p3 gives a number of permutations if 3 people are chosen. And each of these arrangement orders matters. Since we don't care about order, we must eliminate the combinations that this value includes. Since each arrangement contains 3 people, there are 3 permutations of people that are in the same combination. Dividing by 3 eliminates these combinations. Now it says express that. We would have 9 over 3 factorial, 9 minus 3, or 9 divided by 3 factorial, 6 factorial. Okay? Hannah claims that to determine the number of objects of R objects, you divide NPR by R. Do you agree? Explain. Agree. R factorial, this is the NPR is right here. And then we also divide it by R factorial. So basically, to get a combination, you take the permutation and you divide by all the things that are the same. Remember, we looked at combinations with things that are identical. So it's really just a permutation problem, combinations. Okay? Write a formula you could use to determine NCR representing the number of combinations possible which R objects are chosen from in N different objects. So this is the formula. NCR equals N factorial, R factorial, N minus R factorial. So sometimes combinations are also written as NR. The other thing I'm going to tell you is you might want to look for the button on your calculator that is NCR. These are notations commonly used to represent the number of combinations that can be made from a set of N different objects where R of them have used. R is always greater than 0 and N is always greater than R. This is read as N choose R. N choose R, N choose R. Both are valid ways of writing this. Okay, here is a restaurant that serves 10 flavors of ice cream. Danielle has ordered a large sundae with 3 scoops. How many different ice cream combinations does Danielle have to choose from if she wants each scoop to be different? Okay, so what we're going to do is, this is an NCR question, and NCR is equal to N factorial over R factorial N minus R factorial. So N in this case is 10 and C is 3. So we're just going to put in the numbers. 10 factorial over 3 factorial, and this is 10 minus 3, which is 7 factorial. Okay, so this is going to be 10 times 9 times 8, etc. And we are going to divide by, oops, not 7 times 8, see that these all cancel out. Okay, and now we have 3 times 2. Well, 9 divided by 3 is going to be 3, and 8 divided by 2 is going to be 4. So I really have 12 times 10, which is 120. Okay, I want to look at a different question that is very similar. Here, her favorite flavor is chocolate, so she wants one of them to be chocolate. So how many different combinations? And we're just going to look at how they did this question here. So we must choose a scoop of chocolate. This can only happen in one way. We have one choice, one flavor she wants, and she wants to choose one. That leaves 9 flavors to choose the remaining. This is 9 choose 2, because there's 3 scoops, and we've already said that first scoop is chocolate, and then we're saying, well, we have 9 choices to choose 2. 9 options to choose 2. Since we're choosing chocolate and the other 2, we use the fundamental counting principle. So we go 1 choose 1 times 9 choose 2, and they said that's 36. Well, let's just look at this. 9 over 2 factorial, 7 factorial. That is equal to 9 . So we can see that these are all going to cancel each other out. 9, 8, 9 times 4 is 36. So we have 1 times 36, which is 36. So there will be problems where it's a combination problem, but there's 2 different combinations, and then we have to use the fundamental counting principle. Okay. Tanya is the coach of a pole push team that consists of 9 players, 5 males and 4 females. And if we didn't know what pole push is, the Arctic Winter Games, the team placed second, the team from Northwest Territories placed second in the 2006 game. Wow. So you have to push a pole. Okay? So you compete against each other, push their competitors out of a circle. The team that is successful wins. How many different 4-person teams does Tanya have to choose from for an all-male competition? So we have 5 males and 4 females. So we have 5, but we want to choose 4 of them. 5 choose 4. The other way we could write this is 5, 4, like this. That's the other way to write that, the other notation. Okay, and that is equal to 5 factorial over 4 factorial, 5 minus 4 factorial. Okay, which is going to equal over, that's a factorial, 5 times 4 is 1. So we see that we have a bunch that cancel out. We have 5 over 1, or just 5. So there's 5 different all-male teams that can be chosen. Okay, the next question is how many different 4-person teams does Tanya have to choose from with 2 male and 2 female? So what we're going to do is we're going to do the men and the women. So we're going to do, we have 5 choose 2 for the men, since there's 5 men, right? And 4 choose 2 for the women. And then we're going to multiply them together. So let's look at what 5 choose 2 is. That's 5 over 2 factorial times 5 minus 2 factorial, which is 3 factorial. Okay. So it looks like we have 10. So this whole expression is 10. And now let's look at what 4 choose 2 is. So that's 4 over 2, 4 minus 2, minus. It looks like we have 6. So, oops, I should just do 6. So then I have the team is going to be 6 times 10, or 60 different ways. So notice we looked at both cases. How many ways we can choose the men, how many ways we can choose the women, and it's how many ways can you choose men and women. So the word and means fundamental counting principle, means we're going to multiply. Okay, another way to do this question would be to use your calculator and find the button, the C button. It's usually under probability, it's usually under probability, and then you could just put in 5C2 times 4C2. So that's a real shortcut, but sometimes finding that on your calculator may take longer than actually doing the math. But once we get bigger numbers, it's especially going to be important to find that button. Okay, so you can solve counting problems where order is not important by calculating the number of combinations. The number of combinations from a set of n objects where r of them are used in each combination can be denoted by NCR or NR. And they're both written as n choose r. And here's that formula we've been using. Need to know, really, NCR is just NPR divided by r factorial. Okay, this right here, oops, this part right here is just NPR, but then we've also divided by r factorial. It eliminates the counting of the same combinations of R objects arranged in different orders. When solving problems, it may be necessary to use the fundamental counting principle. We just saw that. Sometimes combination problems can be solved using direct reasoning. This occurs when there are combination conditions involved. To do this, follow the steps. Consider the cases that reflect the conditions. Determine the number of combinations for each case. Add the results to determine the total. So sometimes we will have to add. Can be solved using indirect, determine the number of combinations without conditions, consider the ones that don't meet those conditions, and then subtract. Okay, so there were some examples in the textbook about indirect and direct reasoning that might be good to look over.